What is up, YouTube? Woo! Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video now and answer them. Next, progress reports are due today. Today you will be able to explain why some elements are more desperate for electrons than others. And you are going to continue your notes from Thursday. And you're going to learn why are some elements desperate for electrons. Also, by the way, if you want to retake from the quiz we took 3 weeks ago, if you want to retake from this quiz, I posted it for week 15 right here. And everyone, we're going to finish those notes on Thursday. They look like this. Okay. Yesterday we got all the way down to this part, electronegativity. Yep. So that's what I'm going to go over today. Yesterday learned about ionization energy. Now you're going to learn about something very similar called electronegativity. And electronegativity is a measure of how much elements want an electron. The more electronegative you are, the better you are at stealing electrons, which will make you more negative. Which is why fluorine's face looks like this. Oxygen, a little bit less negative because it's not as good at stealing them. Nitrogen, kind of in between. Carbon and hydrogen are not very electronegative, so they're actually happy. Okay, so electronegativity, remember how much an element wants an electron. And then, so if electronegativity is how much an element wants an electron, try and think of a real life example where some people or objects are desperate for something. For example, here are some things my 4th period came up with. Yep. Next, the element with the most electronegativity is fluorine. So electronegativity, as you move up on the table and go to the right, so all of these elements are more electronegative than these, and all of these elements are more electronegative than these. And fluorine is the very most electronegative of all the elements. And I'm going to go over the reason now. The first one is that it is super close to a full orbital. It has 7 valence electrons and it needs 8. In fact, all of the elements in this column have 7. So they're all very close and very electronegative because they want a complete orbital. So that's partly why fluorine is really electronegative. Also, fluorine's orbitals are very close to the nucleus. Remember, the nucleus is positive, which attracts the electrons out here. So since the electrons in fluorine aren't very far away, it makes it very strong and powerful electronegativity. So please put that in your notes too. And I want to explain why, as you go up in the table, why does it get more ionization energy and electronegative? So part of the reason is the rings on the inside are stronger. This ring is a lot stronger and more attracted to electrons than this ring. The reason is, remember, the nucleus has protons, which will pull everything close to it in, all these electrons in. But the farther you get away from the nucleus, the weaker these orbitals are going to be because they're farther away from the nucleus. So it's harder to steal electrons from the inside rings because they're closer to this, but the rings out here are easier to steal from. Also, elements are more desperate to get these orbitals filled in first because those are more stable. Okay, so that's part of the reason why, like helium only one ring, very powerful though, because it's very small and very hard to steal an electron from, whereas argon has a ton more rings, so it's much easier to steal an electron from it. The next one, so the reason why when you have elements on the left, these ones not very electronegative, these ones very electronegative. The reason is because every element's mission is to get a full or complete orbital. So lithium right now has one valence electron, but it's not happy like that. It wants to be like this. It wants one nice, happy orbital. So it prefers to lose this electron so it can go back down to a complete orbital. That would be a lot more stable. Fluorine is the opposite though. Instead of losing an electron to be full, it needs to gain an electron to be full. And that's why fluorine really, really is powerful and wants an electron, because it wants to be a complete orbital and it's very close to having it. Yep. So just remember, we'll go over this more in our next unit with bonding, but all of these elements in this column, they all have 7 valence electrons, but they all want 8 because they'll be more stable and happy if they have a full orbital. So these are all going to try and steal 1 to get 8. All of these, though, these will all try and steal 2 electrons so they can get up to 8. All of these will try and steal 3 electrons, so these ones can get to 8. All of these and 4 are in the middle. They could either gain 4 or lose 4, so these ones can go either way. Also, 4 is half of 8, so it's a little bit more stable than these that have to choose sides. So these ones usually don't gain or lose 4. These ones, 3, they're close enough to drop back down and go either to 2 or to 8 valence electrons if they lose 3. These ones try and lose 2, and these ones will try and lose 1. So that's probably why these elements, they want to lose electrons, so they're not electronegative. These ones really desperately want to gain electrons, so they're more electronegative, so they can get up to 8. And the last part, francium. Francium is the biggest element because it has the most orbitals and has the least attractive force or electronegativity. And here's a comparison. So here's francium. It has 7 orbitals. Tennessine also has 7 orbitals, but tennessine has a lot more attractive force. The electronegativity is holding it in more, whereas francium is a lot more spread out. So that's what makes francium the biggest one. And you'll notice the trend for atomic size is the opposite of electronegativity. So atomic size, atoms get bigger as you go down and to the left, whereas atoms get more electronegative as you go up and to the right. Yep, once you have that, please write a summary, and then you're all good to go. Thank you so much everyone for staying with me the entire time. Bye.